Hello, welcome back. On the second part of the determination of the nature of forces in the members of a frame. I actually paused the first video because I realized I've done 10 minutes, and when the videos are too long, it becomes very boring to the subscriber. That is how come I pause at exactly 10 minutes and a little bit seconds. So now we are back. What we did in the first video was to take the joints of the phrase of the truss into consideration, and at each joint we moved in a clockwise movements to actually give letters to the members. Having done that, I personally listed them all here for the purpose of explanation, but you can keep them in your heads if you know what you are doing. So at joint A, we have MG. MG is actually a reaction. So you could see here, I've cancelled it with a pencil. We are looking at members at a particular joint, not reactions or loads. We have J1 at joint A. At joint A, we have J1, J1, which is this member, Now we move to the force or vector diagram in a similar fashion in which the numbers or the members has been lettered. It is J1, not 1J. At joint A in a clockwise movement, we have J1, J1. We come back to the force diagram or the vector diagram. This is J, and 1 is here. So J1, we moved down. J1, we moved down. So when we move down, we quickly come back again to the space diagram. And considering joint A, what is going to happen? There should be an arrow at joint A, near joint A. And the question is that arrow pointing downwards or upwards? Is it pointing downwards or upwards? Here, realize the member was J1 and remove from down up to top. Sorry, remove from top to down. So at this joints, J1, joint A, the arrow will be pointing towards the junction or towards the joint because it was J1. And when you come back to the vector diagram, J1, we actually descended. We have another member, 1M, at joint A. 1M, we move to the vector diagram. What happens? 1M. 1M, there is no direction because 1 and M are all on the same point. So when that happens, it means 1M, this member, 1M, which is this member, it means it has a zero force. When you even come back to the forces or the magnitude in that member, M1, it was 0. So when it is 0, my brother, my sister watching me, the nature of the force becomes dash. It becomes dash. There is no nature of force in it because the magnitude is 0. Because 1 and M are all lying on the same point. It has no force, and for that matter, the nature will be 0. Now, when it comes back to here, there will be no arrow. No arrow. So this member in actual sense will not be there. In redrawing the frame, this member 1M will not be there because it will not be serving any purpose. No force and no nature. So it will not serve any purpose. So you have to when the truss is being redrawn, that member will have to be removed because it has 0 force. Now when you come out to joint B, we have 1J, J2, and 2-1. We start with 1J. With 1J, we move back to the force diagram or the vector diagram. This is 1, and where is J? This is J. 1J at joint B. At joint B, 1J. 1J. is referring to this member. So what happens to 1J? We moved up from 1 to J. So when you go to joint B, 1J, this member, we moved up. So at joint B, the arrow on this member will be moving up. Will be moving up because on the vector diagram, it was 1G. We moved up. So at joint B, this member 1G at joint B will move up. At the same joint B, you have J2. So J2, when you move back to the force or the vector diagram, J2 is this. So we are moving in this direction. We are moving in this direction. So when you come back to the space diagram at joint B, remember at joint B, J2 is this member, and at joint B, the arrow would have to be this. It will have to be this at joint B because we move from J to 2. So the direction to point towards the junction. At that same joint B, we have member 2, 1. Member 2, this is 2, 1. This member 2, 1. You come back to the force diagram, 2, 1. This is 2, and this is 1. So we move from 2 straight down to 1. From 2 straight down to 1.